Today we are going to look at the quotient rule. Yesterday we looked at product rule, which is where two functions were multiplied together. And today we're going to look at the quotient rule, where two functions are divided. So the quotient rule is basically d dx, which just means derivative, of some function f of x divided by some function g of x. Okay? So something divided by something, okay? And so that is, here's how I've always done it. Bow de toe, which is bottom times the derivative of the top. So g of x times f prime of x minus bow de toe minus toe de bow. So top times the derivative of the bottom. So f of x times g prime of x all over bow. In other words, g of x squared. All of g of x times g of x. So another way to look at it is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Bottom times bottom. So bow de toe minus toe de bow all over bow. Okay, just real pretty simple. Okay, and that d dx there just means take the derivative of. Okay, so example 1. d dx of 5x minus 2 over x squared plus 1. So again, I'm going to write out my chart like I had you do it before, or like we did in class yesterday. F of x, in this case, is 5x minus 2. G of x is x squared plus 1. F prime of x is 5. G prime of x is 2x. Okay, so bow de toe. So bottom times the derivative of the top. So x squared plus 1 times 5 minus bow de toe minus toe de bow. So 5x minus 2 times the derivative of the bottom, 2x, all divided by bow, which is just x squared plus 1 squared. Okay, now we're going to distribute and do some algebra. So that gives me 5x squared plus 5 minus, we'll distribute my 2x through, so 10x plus 4x all over x squared plus 1 quantity squared. Okay? We'll combine it all together. 5x squared and negative 10x, that should be x squared, shouldn't it? Yes, sorry, my mistake. So negative 10x and 5x squared is negative 5x squared. 4x stays the same, so positive 4x and positive 5. Again, this is all still over x squared plus 1 squared. You don't necessarily want to FOIL that out. Okay, moving on. Okay, d dx of tan x. All right, well, I can rewrite that as, well, tan is just sine over cosine. Ooh, what do we have? We have quotient rule. Okay, so again, I'm going to do my chart, or my f and g, and my f prime and g prime. So f of x is sine x, g of x is cosine x, f prime of x equals cosine x, g prime of x equals negative sine x. Okay, so let's look at this. All right, bow de toe. So bottom times the derivative of the top. So cosine times cosine. All minus bottom times the derivative of the top times the top minus the top. So that's sine x times the derivative of the bottom, which is negative sine x, all over the bottom squared. So bottom squared is cosine squared. All right, so that gives me cosine squared x. Well, negative times a negative is a positive. Sine squared x all over cosine squared x. Ooh, cosine squared plus sine squared is 1. You should know that. That's your Pythagorean. So 1 over cosine squared x. 1 over cosine squared x. Well, 1 over cosine is, again, it's another of your identities. It's secant. So it is secant squared x. Memorize d dx of tan x is secant squared x. Okay, moving on. All right, these are 4 trig memories. So more trig memories. Add these to your memory list. Memories. Okay. d dx tan x is secant squared x. d dx of secant x is secant x tan x. And all of these I could prove to you. These are all quotient rules. But I'm just proving the first one to you. This is the most common one. The derivative of tan x is secant squared x. You will see that all the time. Know that just the way you know sine and cosine. So d dx of cotangent x is actually negative cosecant squared x. And d dx just means derivative. Here you go. All right, one more example, and then we will be done. This actually is a harder example, but it's a good one to see. Okay, so we're going to say x to the 4th. I want d dx of x to the 4th all times 1 minus 2 over x plus 1. Okay, so the first thing I'm going to do there, I'm actually going to distribute my x to the 4th through. So I now have d dx of x to the 4th minus 2x to the 4th, or x plus 1. Well, if I take the derivative of the first part, I can do each piece, right? So d dx of x to the 4th minus d dx of 2x to the 4th over x plus Okay, that one's just easy, right? d dx of x to the fourth is 4x cubed. And then I have my minus sign. Ooh, well now I have to do quotient rule. So let's come over here and let's do quotient rule. F of x here is 2x to the fourth. G of x is x plus 1. F prime of x is 8x cubed. G prime of x is 1. So bow, ditto. So the bottom, so x plus 1. Going back to my rule, let's actually work my derivative over here. So the bottom, which is x plus 1, times the derivative of the top, which is 8x cubed, minus bow d-toe minus toe, which is the top, 2x to the fourth, times 1, well that's just 1, all over bow, which would just be x plus 1 squared. Okay, so let's look at this. All right, I can distribute that 8x through. So I now have 8x to the fourth plus 8x cubed minus 2x to the fourth all over x plus 1 squared. Well, combine those together and I have 6x to the fourth, 2 minus 8 plus 8x cubed all over x plus 1 squared. Combining all that together, 6x to the fourth plus 8x cubed all over x plus 1 squared. And you are completely finished. I will let you stop there. Okay?